Hello friends, from this video lecture we are going to start the fourth unit, that is wireless LAN, and the few points of this topic. So first one is the introduction to Wi-Fi and the IEEE standards for the wireless communication and for wireless local area network. So daily we are using the Wi-Fi network. So by using access point, we are using the Wi-Fi network to access the internet. So in wireless LAN, if suppose the wireless device is available with us, and if we want to connect the wireless device to Wi-Fi network, some standards are need to consider. Then only our device get connected with the access point or the Wi-Fi router. So all these things we will discuss in this point, and IEEE standards for this wireless communication technique for local area network. So this Wi-Fi is nothing but wireless fidelity, mainly used to connect the devices wirelessly. So wireless fidelity is generic term to IEEE standard 802.11 for wireless local area network. The concept of wireless local area network is based on wired. Also we can compare this with wired local area network, where we can connect the networking devices in the LAN through transmission media, that is copper or fiber optic kind of guided media. But in this case, in case of wireless local area network, the devices get connected with each other by using radio signals. So Wi-Fi is wireless technology that uses radio frequency with a specific carrier frequency depending on IEEE standard to transmit data through the air. So Wi-Fi network connects computer to each other, to the internet and to the wired network. So the number of gadgets who can access the Wi-Fi network wirelessly can be connected to the network. So at that time, the devices which are available in the Wi-Fi network will communicate with each other, and in this case it is observed that the access point or the nodes available in the Wi-Fi network, they are connected to the wired network or a backbone cable. So as I said, this Wi-Fi technology with IEEE standards 802.11. So 802.11 primarily concerned with the lower layer of the OSI reference model, where the physical layer and data link layer compared with the IEEE 802.11 protocol stack. So here we can able to see the 7 layers of the OSI reference model, and the comparison is done with the bottom 2 layers of the IEEE 802.11 reference model, where the basic lower 2 layers, that is physical layer and data link layer, are important, where the modifications are observed. So instead of the wired communication, here due to the radio communication or wireless kind of devices or circuitry is mainly observed at physical layer, and LLC and MAC, logical link control and media access control, again compared with the data link layer in OSI reference model. So data link layer we know very well deals with the logical link control and the media access control. and the basic working principle of the data link layer or the services offered by the data link layer that you know very well, that is framing kind of operations, and depending on the MAC and LLC, the services offered. Then physical layer. So this physical layer convergence procedure, PLCP, deals with all the wireless or radio related hardware, the connections with the specific carrier frequency, modulator, demodulator kind of circuitry. And physical medium dependent means the specific carrier frequency depending on the IEEE standard 802.11 A, B, C, N kind of standards, different carrier frequencies, and according to that the circuitry you will get in the physical layer of the IEEE standard 802.11 reference model. We will see in detail about the 802.11 standards. So IEEE 802.11 is a set of media access control and PHY, that is physical layer, specifications for implementing the wireless local area network, that is WLAN, computer communication with the carrier frequencies 2.4 GHz, 3.6 GHz, 5 GHz and up to 6 GHz frequency bands. So these are the standards available under this 802.11, 802.11b, then 802.11a, then 802.11g, N, and finally 802.11 AC. We will see one by one the details of these IEEE standards. So first one, 802.11b, which is invented or developed in 1999, where its operating frequency is 2.44 GHz. The theoretical speed of this particular standard or the hardware which is designed by assuming this 802.11b gives 11 Mbps of speed in the coverage area of 30 meter but practically we are not getting this much of speed and coverage area. So usually this 802.11 gives 4 to 6 Mbps of speed and limited coverage area 100 to 150 feet. It limits the number of access points in the range of each other to 3. If suppose number of devices increase in this particular in the coverage area, so at that time the performance of this particular standard get degraded. So due to the implementation cost and least inexpensive, this is the most popular IEEE standard for the Wi-Fi. The main drawback of this particular standard is that interference from mobile phones and Bluetooth devices which can reduce the transmission speed. So due to the interference you will get variations in the data rate. The working of this particular 11b standard is based on DSS, that is direct sequence spread spectrum technology. The next IEEE standard 802.11a, which is introduced in 2001, and its typical operating frequency is about 5 GHz. So this is less popular as compared to the previous standard 802.11b, but advantage is that less interference, theoretical speed of this particular standard is 54 Mbps, but practically we are not getting this much of speed. 15 to 20 Mbps is the actual speed, again depending on the environment or the implementation area, variations in the data rate. The coverage range is in between 50 to 75 feet only. Initial investment or the costing is more. Highly obstructed. So here again the interference of the neighboring radio signals. This is the main drawback, not compatible with the previous standard, that is 802.11b, which is working on DSS, and this particular 802.11a is based on frequency division multiplexing. So if suppose the device is working on 802.11b standard, so that particular device will not work in 802.11a network. The next standard 802.11g, which is introduced in the year 2003. So in this particular 802.11g standard, you will find the combined features which are provided with 802.11a and 11b. So due to this reason, the devices which are based on this particular standard will work in 11a and 11b network. The coverage range is about 100 to 150 feet. Theoretical speed as per the design or without obstructions 54 Mbps, but practically we are getting this speed in the range of 20 to 25 Mbps only. The operating frequency of this standard 2.4 gigahertz. So this particular standard is compatible with 802.11b, because this particular 802.11g also uses frequency division multiplexing. Next standard 802.11n standard, also known as wireless N standard. So this 802.11n ratified in the year 2009. So this particular N standard is built on the previous 802.11 standard by adding multiple input and multiple output scheme, that is MIMO scheme, and the operating frequency in the range of 2.4 gigahertz and 5 gigahertz. The data rate for this particular 802.11n is up to 300 Mbps. So this particular standard is compatible with the previous 802.11b and G network. So here you will get increased speed and the better coverage area as compared to the previous IEEE standards. And finally 802.11 AC is also based on 802.11n, which is modified but published in year 2013. And as the previous standard, that is 802.11n, is working on MIMO model, this particular AC standard is also based on multi-user MIMO model. Then it utilizes dual band wireless technology. This is the main advantage of this AC standard. It supports both the devices which are working with the operating frequency 2.4 gigahertz and 5 gigahertz, and due to this reason you will get backward compatibility. So the devices which are designed with the Wi-Fi standard 802.11b, G or N, so these devices will work in the Wi-Fi network with the standard 802.11 AC. So here data rate you will get up to 1300 Mbps with the carrier frequency 5 gigahertz, and the data rate or speed 450 Mbps on the carrier frequency or with the carrier frequency 2.4 gigahertz. So after the discussion of the different IEEE standards, we will see the different elements of Wi-Fi. So I think this is no need to discuss about the elements of the Wi-Fi. We know very well in the Wi-Fi network you will find one access point. That access point is always connected, or you will find connected with the backbone cable or the service provider cable, and this particular access point is responsible to provide wireless service to connect the devices like laptop, Wi-Fi adapter based computers, mobile phones or handheld devices. So in Wi-Fi you will find the elements like access point. So access point is the wireless LAN radio trans receiver, or simply we can say that base station that can connect to one or many wireless devices simultaneously to internet. So this access point you can compare with the hotspot which is observed with the mobile phone or any wireless handheld device. So that particular device is responsible to provide the internet service or wireless service to the devices which are available in his coverage area. Then Wi-Fi card, which is observed in the computer or laptop or desktop computers, they accept the wireless signal and relay information. Sometimes the Wi-Fi dongle you will find with the electronic gadgets, so they can be external or internal. So in the laptops you will find laptops, mobile phone or handheld devices, you will find the internal Wi-Fi card. Sometimes with the desktop computers you will find the external Wi-Fi adapter or dongle. So that particular hardware is responsible to connect that particular desktop to the Wi-Fi network. Then to protect the Wi-Fi network and security purpose, safeguards. So here firewall settings and antivirus protections are provided with the Wi-Fi. So here these are responsible to protect the Wi-Fi network, that is uninvited users, and keep the information secure. Now we'll see the Wi-Fi network technologies. So here topologies. So usually in case of wireless LAN or Wi-Fi network you will find two kinds of topologies. So first one is a peer-to-peer topology and access point based or Wi-Fi router based topology, also known as the infrastructure kind of topology or infrastructure mode based topology. So first we will see the peer-to-peer topology, where the Wi-Fi enabled devices will communicate with each other. So here in the picture we can able to see the two laptops are connected with each other. Also these two laptops are connected or communicating with the handheld device or the mobile phone. So in this case, in case of peer-to-peer kind of topology, the access point is not required. The client devices can communicate with each other directly. So client devices means the devices which are available in the network. So here it is useful to create wireless network easily and quickly. Then in case of infrastructure network based topology, you will find the central base station or the Wi-Fi router or the access point. So that particular access point is responsible to provide the Wi-Fi service to the number of clients available in the network, either permanent or temporary devices. So here in this picture we can able to see the 3 laptops are communicating through this central base station or the access point. Also the mobile phone is communicating with the remaining clients or the laptops. So the client communicate through the access point. So every time, if suppose the devices want to communicate with each other, so at that time they should first communicate with the base station or the access point, and access point will provide the information to the another client. So any communication has to go through the access point. So as I said, if suppose number of devices want to communicate with each other, so at that time in between the clients you will find the access point. So if the mobile station like PDA, handheld device, computer, laptop, cell phones has to communicate with each other, mobile station, it need to send the information to access point first, and then access point send the information to the destination mobile station. So every time the central access point you need to consider. Then the working of the Wi-Fi. So here, as I said, in case of Wi-Fi network, you will find the central hotspot. That particular central hotspot will provide the Wi-Fi network. So a Wi-Fi hotspot created by installing an access point to an internet connection. So if suppose that access point or from the particular access point you want to access the internet, so at that time that access point must be connected to the backbone cable where the internet connection is available. So an access point acts as a central base station through which all the data communication takes place. So when Wi-Fi enabled device encounters a hotspot, the device can then connect to that network wirelessly. So if suppose that particular network is with the ID and password, so at that time the client or the device should provide the login ID and password, and after that the device get connected with the Wi-Fi network. A computer adapters translate data into radio signal and transmit using antenna. So as I said, the Wi-Fi dongle or the Wi-Fi card which is available inside the laptop, who is responsible to convert the digital information to the radio signal, and then that particular module or the dongle is responsible to get connect with the Wi-Fi network. So a wireless router or the central station receives the signal and decode it. So router send the information to the another client. So central access point is responsible to take the data from the clients and forward it to the another client. So every time the central router or access point will come into picture. Then many access points can connect it to each other via Ethernet cable to create single large network. So if suppose somebody want to increase the coverage area, so at that time the network engineer will install the number of access points, or he will connect number of access points to the Ethernet cable or the backbone cable such a way that to increase the coverage area. Then in this particular Wi-Fi technology, you will find with the data link layer CSMA, CA kind of protocols for data transmission during the data transmission and reception. So CSMA carrier sense multiple access and collision avoidance, because if suppose number of devices want to communicate to access point for data transmission, or suppose number of devices want to send the data frames to the single base station, so at that time the priority is most important, otherwise the frames get, or the information available which is available in the frames get damaged due to the collision. So at that time carrier sense multiple access and collision avoidance kind of protocols are mainly observed with the access point. Then depending on the availability of the access point or the radio channel, the clients will send the frames or the information to the access point one by one. So as I said, carrier sense multiple access with collision avoidance is mainly observed with the access points, which is working with the data link layer. Then mobile station sends its packet. It checks to see if someone else is sending the information. Only when the medium is free can an mobile station send the packets. Means if suppose radio channel is not available or access point is not ready to accept the packets or frames, then the protocol will provide a certain time period to the mobile station to wait, or that particular mobile station will wait for some time to get the service from the access point. If some station is sending or receiving signal, the mobile station that intend to send will generate the random waiting time and wait for its turn. That means the client will, or the mobile station will wait a certain amount of time. If several mobile stations are waiting for their turns, since their waiting time are randomly generated and thus not equal, they will not start sending simultaneously. So in this way the collision problem gets solved with the help of this CSMA CA. Thus collision, two or more mobile stations sending signals simultaneously is avoided. So in this timing diagram we can able to see station A, B, C, D and E. These are the mobile stations want to communicate with the access point, and depending on the contention window, interframe spacing, back of time and remaining back of time. So here back of time and remaining back of time are most important. During this particular time period the packets of frames get transferred, and at that time the another or second priority mobile station will wait for that particular time period. After the completion of that particular back of time, the next device get accessed. So here station A, then station B, station C, station D and station E will get the service to access or to send the frame to the central access point. So in detail about the concepts of this particular DSSS, the interframe spacing, contention window, all these things we will see in another lecture. So here the CSMA CA kind of protocols which are working with the data link layer plays an important role to avoid the collision. Then to secure the Wi-Fi network, different protocols are there. So to protect the Wi-Fi network, usually we will find the wired equivalency protocol, that is WEP protocol, WPA, Wi-Fi protected access, WPA2, extensible authentication protocol, EAP protocol, and the hardware and software based firewall protections can be provided with the Wi-Fi network to protect the user data or the information which is available in the network. Then the advantages of this particular Wi-Fi technology, the first one is the freedom. So here we can work from any location that we can get a signal. By sitting anywhere we can send and we can receive the information. Only the initial investment or setup cost is need to consider, and the main advantage is that no cabling is required. Then the flexibility. So flexibility point of view, the quick and easy installation to temporary and permanent space. Only a single access point is required to install in the network. After that, that particular access point will provide the Wi-Fi coverage area or the coverage region. And the scalability can be expanded with growth. So as I said, depending on the requirement or the coverage area, simply by installing or by hooking the number of routers or access point in the infrastructure area network, we can increase the coverage area. The mobile access, we can access the network on the move. So any handheld device like mobile phone or any tablet kind of devices or laptops, we can access in the network anywhere by sitting anywhere. Then the disadvantages of this Wi-Fi. The first one is the speed, slower than cable. Obviously, as we discussed in the wireless concept, where the wireless signal get obstructed due to the environmental effects and the propagation losses. So due to this reason, we are getting slower speed as compared to the direct physical media or cable based network. Then the range affected by various mediums, where travels the best through the open space. Means if suppose in between the access point and client or the mobile station there is no any obstruction like glass walls, wooden partitions or buildings, so at that time definitely we are getting limited coverage area. And if suppose free space is there, or in case of outdoor environment, you will get better performance. Then the security issues, greater exposure to risk because of the unauthorized access. Then compromising the data. So due to the variations in the data rate, we will not get the better performance every time. We will not get the fixed bandwidth. So you will get the variations in the data rate. Then denial of service. If suppose this central access point because some problem is there with the access point, definitely the whole wireless network get collapsed. This is the main problem of this Wi-Fi network. So this is about the IEEE Wi-Fi standards.